Hello guys, this is Ahmed again. Today we're going to talk about the circuit breaker and how does it function in our circuit. And we're going to talk about how can we build our direct online circuit. And we're going to show you some pictures or images for the circuit breaker and how does it function in our circuit. And here we see here in our this image that we have a circuit breaker. This is a miniature circuit breaker that I'm pointing at now. Miniature circuit breaker is automatically disconnect load when short circuit happens, which means if a short circuit happens, if two lines touch each other by mistake or by any accident, this should be tripped off or trip off, so switch itself automatically from on to off in order to protect our circuit from short circuit and order not to burn our device or motor or burn our load, some damage happens to our load. And from its properties, it's automatically disconnect load when short circuit happens. It contains an arc chamber, and the arc chamber is, I'm going to show you what does an arc chamber means. It's directly connected to the circuit, so it is attached to the circuit and it's directly connected to it. And we do not need, if a short circuit happens, we don't need to switch off the power from our circuit or from the load. And this load could be a machine, could be a motor, it could be a production device in your factory or in your industrial area or the workplaces that you're working on. And here we have the selector switch isolator and this circuit breaker. It could it varies from the ampere. It can vary is from 6 amperes and up to 125 amperes. All right. And we have the selector switch isolator, which is selector switch isolator is a switch that we are switching on or switching off power from our circuit. It's manually switch off power to isolate the load and works on the concept of arc chamber. I'm going to explain what an arc chamber means. Not directly connected to the electric circuit, which means in order that you can switch on your circuit or switch off your circuit, switch on or switch off your load, whatever this load is, you have first to disconnect the circuit breaker by switching off this switch, which is a circuit breaker. So it's we can say it's an auxiliary device that can be used beside the circuit breaker, but we cannot use it directly in our circuit. All right, and this is a load break switch. The load break switch can be used solely like the circuit breaker, and we can because it's directly connected to our circuit, and it can be used to manage switching off, switching on or switching off the power from our circuit. It's manually used, so and it manually used, so we have to manually switch on or switch off the power from our circuit using this load break switch. It has an arc chamber. It's been directly connected to the electrical circuit. All right. So we have explained what kind of switches that we are going to have in our circuit, and we're going to talk about how does a circuit breaker works. Here we have a miniature circuit breaker, which you have spoken about moments ago. And how does it work? It has an arc chamber. You can see here there is a bimetal strip right here. Alright, and this looks like it is switched off. When it's switched on, when this one is switched on, it touches here the metal here of this type of metal. These are two types, two types, two different types of metal, that one of them stretches when a short circuit happens, and then this one enters the bends, between the bends here, and when this one expands because of high temperature that happens because of the short circuit, it just make this strip jumps, and the switch is the circuit breaker turns off the power from our circuit. And this is how it works, and this is arc chamber that we are talking about. Now we're going to see how does a direct online circuit looks like here. Right here we have in this demonstration that we have two types of circuits, as I have spoken about in my previous video, that we have the power circuit, which I have highlighted here with the black lines. All right, we have here the power panel or the distribution panel that comes from it, the power source, which is three hot lines, 380 volts or maybe 500 volts. That depends on your type of the type of your motor and the motor characteristics. And we have here also, if you can see here, we have put the miniature circuit breaker. It means that we are putting it as a protection device. We put it before the contactor and the overload. I'm going to talk also about our overload, how does it work and what is its function. Okay, and we have here also, I have highlighted our control circuit with other colors, and I'm going to explain it. Okay, first of all, we have here the power circuit, which goes here. It looks very smooth. It looks nothing complicated about it. It's 3 lines going in and going out, and then going in the contactor and going out to the and the contactor is connected to the overload, and the overload is connected directly to the motor. It's 3 ins, 3 out, and 3 out going to the motor, and this is our power circuit. And what is our control circuit? We take a hot line from here and we connect it to our stop button, and then we take the same hot line that we have connected to the stop button, it's highlighted here in brown, and then we connect it to the on button, the start push button, and then we connect it here to the overload normally close point, and then we connect it here to the other normally close point here. These 2 points are connected to each other, and these 2 points change states in case of overload voltage that happens or overcurrent that happens in our circuit. And then we connect it here to the A1, so we are feeding our contactor through our overload from here. All right, so we have put the overload first, because in case of an overload, it will sense the overload voltage or the overload current, and it will strip off, so it cuts the power from the contactor. This is the first condition that we are setting in our direct online circuit settings. And then the A1 point is connected to the initiation point of our sorry, just one moment. Alright guys, we're going to continue our demonstration regarding this direct online circuit. We have spoken that that we have 2 points here in our overload that is normally closed, and we are feeding this normally closed contacts, which is have a property of if there is an overload voltage, it will trip, and the overload will switch off the circuit In order to give the function, or we just give a property for the overload function, we just pass the control, the power to the control circuit firstly through our overload, and then we give the second point from our overload, which is a normally closed point, to feed our contactor. So the contactor now feeds from our overload, and this is a great function that we can use in our control circuit in order that if an over voltage that happens or an overcurrent happens, that it's going to trip the overload, and then sequentially it's going to switch off our contactor. And then the contactor takes from the A1, and this point is an A1, this is the feeding point of our contactor, and then it goes here, the neutral line, and goes back to our distribution panel. Okay, and this push button, this is an off push button when we wish to switch off power from our circuit. Whether we go manually and switch off this circuit breaker, or we can make a facility that we build a box beside the motor, the actual base of the motor, because this circuit breaker resides in the distribution panel. So you're not going to the distribution panel in order to switch off motor, but you rather than this, you build a box beside your motor in order to facilitate or make it easy for yourself to switch off your motor. So we put a box beside the motor, and we bought here the switch off button, or the stop button and start button beside it. So what is this red wire that we can see here? This the red wire, we call it a latch. What is the latch? It's we say we latch our start button. Why? Because when you press on the start button, the power circuit or the motor starts for about 6 milliseconds, and then it turns off. So you will never, if you continue pressing on the start button, it will work for more than 6 milliseconds, maybe as much as you press on the start button, it will continue working. But you don't want this. You want, when you press on the start button, it works and continuously until you decide to stop the motor and press on the stop button. But now we're going, in order that we press on the start button and it continues working, we just press on the start button and we latch the start button. How does we do it? We take a wire from the outgoing phase from our push button, stop button, and we give it to the normally open point contact in our contactor, the normally open in our contactor, and we give it here to the other point, same point. It's on the same path. These both are connected to each other when the contactor is open. So these points, this point, the normally open contacts this here and this one here, has the properties that it is open, which means you cannot pass a current through these 2 points. And when the contactor is open, or contactor, you initiate the contactor for just 6 milliseconds, these 2 points change from normally open to normally closed, which means if it's normally closed, it's going to pass the current. So if we do this, the contactor will continue working. So when you press for 6 milliseconds, the contactor changes states, and then the normally open becomes normally closed, and it passes current. And if it's passing current, the current will continue passing and the contactor will not have to stop. It will continue working until you press on the stop button. And this is all about the direct online circuit. And very important not to forget the neutral wire here that's outgoing from the A1 to our distribution panel back again. Thank you guys for watching this video, and have a good day.